Everyone, I am Rakshita studying Electronics and Communication Engineering in Sri Venkateswara College of Engineering, Bangalore. Today we are going to discuss on a subject Principle of Communication System, subject code BEC 402, topic AM circuits, transistor modulators. Let's know them one by one. Introduction to transistor modulators. Transistor modulators are electronic circuits that use transistors to perform amplitude modulation of a signal. They are an important component in radio transmission and other communication systems, allowing the mixing of a carrier signal with a modulating signal. Transistor modulators are essential components in amplitude modulation circuits. They play a crucial role in varying the amplitude of a carrier signal to encode the audio signal. The transistor modulator helps in superimposing the audio signal onto the carrier wave for transmission. Let's move forward to the next slide. Principles of amplitude modulation, carrier wave. A continuous high frequency signal that acts as a base for the modulation. Modulating signal. The lower frequency information signal that is used to modify the amplitude of the carrier. Modulated wave. The final output signal with the modulating signal encoded in the amplitude variations. Let's move forward to the next slide. Here you can see the amplitude modulation contains message signal and amplitude modulated signal. Here you can see the graph drawn between the amplitude versus time. Transistor modulator circuits. Common emitter, common collector and common base are the transistor modulator circuits. Common emitter uses a transistor in a common emitter configuration to mix a carrier and the modulating signals. In common collector, it uses a transistor in a common collector configuration to provide power amplification. Common base uses a transistor in a common base configuration to provide impedance matching between the stages. Here you can see the physical diagram, symbolic diagram and the constructional diagram. Let's move forward to the next slide. Types of transistor modulators. There are two main types of transistor modulators used in amplitude modulation circuits: Class A modulators and Class C modulators. Class A modulators are known for their linearity and are suitable for high audio applications. Class C modulators are more efficient but less linear, making them better suited for low power applications. Types of transistor. Transistor contains BJT and FET. BJT is known for bipolar junction transistor and FET is known for field effect transistor. Under BJT we have NPN and PNP transistors. Under FET we have junction FET and MOSFET. MOSFET is known for metal oxide semiconductor FET. Under junction FET we have N types and P types. Under MOSFET we have depletion enhancement mode. Under depletion mode, we have N channel and P channel. Under enhancement mode, P channel and N channel. Operation of transistor modulators. Transistor modulators operate by varying the amplification of a carrier signal based on the audio input. The audio signal modulates the biasing of the transistor, which in turn modifies the amplitude of the carrier wave. This modulation process results in the creation of sidebands that carry the audio information from the transmission. Advantages of transistor modulators. Transistor modulators offer better efficiency compared to vacuum tube modulators. They are more compact, reliable, and cost efficient for amplitude modulation circuit applications. Transistor modulators also provide improved frequency response and modulation accuracy. Let's know the disadvantages of the transistor modulator. Transistor modulators may introduce distortion in amplified signal affecting the audio quality. They can be sensitive to temperature variations and require proper thermal management. Transistor modulators may require additional circuitry for biasing and stabilization. Design consideration for transistor modulators. Proper biasing of the transistor is crucial to ensure optimal linearity and efficiency. Selecting the appropriate transistor type and configuration is essential for the desired modulation characteristics. Careful impedance matching and filtering are necessary to minimize distortion and interference. Application of transistor modulators. Transistor modulators are commonly used in broadcast transmitters for AM radio stations. They are also employed in RF power amplifiers for various communication systems. Transistor modulators find application in audio processing equipment and signal generations. Future trends in transistor modulators. The development of integrated circuit technologies is leading to more compact and efficient transistor modulators. Advances in semiconductor materials and fabrication techniques are improving the performance of transistor modulators. Research is ongoing to enhance the linearity and distortion characteristics of transistor modulators for high fidelity applications. Challenges in transistor modulators. Ensuring consistent performance across different operating conditions and frequencies is a challenge in transistor modulator design. Managing power dissipation and thermal effects become critical in high power applications. Balancing between linearity and efficiency remains a constant challenge in transistor modulator optimization. Conclusion. Transistor modulators play a vital role in amplitude modulation circuits by enabling the modulation of audio signals onto carrier wave for transmission. Despite challenges, advancements in semiconductor technology are driving improvements in transistor modulator performance. Understanding the principles and design considerations of transistor modulators is essential for optimizing amplitude modulation circuit performance. Thank you for watching my video. Please do like, share and subscribe my channel.